it's a lot more interesting than graphing polynomials. Okay. So 5.5, graphing sine and cosine. Okay, and see what they look like. You might see some of that, like if you look online and different things like that, you might see some of those cosine and sine waves. We'll see those more in detail. What are we going to do? We're going to graph just what they look like normally with no transformations. Then we're going to put a number out in front and see what happens. Then we're going to do something with the input variable and see what happens to it. And then we're going to end up subtracting and adding something on the outside, which starts shifting some things with the waves itself. And then we'll do a quick little application problem and how we can create one of these with some information. Okay. Transformations. Let's go back to algebra real quick. First function. What type of transformations are happening to it? Who remembers? Yeah.
That's a reflection across the x-axis, I believe.
Yep.
Dilation vertically at stretched by 2. And it's being translated 1 unit to the right.
Okay, very good. So if you know, the outside tells you if it's being stretched or compressed, right? We know that from the past. The negative is going to reflect it. That doesn't change with this when we start learning about those. And what's inside is going to be moving it horizontally. Okay, very good. How about this one over here? What's happening to this guy? I agree. What's that?
Horizontal stretch by 1/4.
Vertical compression by 1/4. And then what's the negative one doing?
Horizontal stretch.
Horizontal would be if this was in, like if this 1/4 was inside the parentheses, we're looking at a horizontal one.
Okay.
So this would be a vertical compression. I'll just do VC. And we're gonna go, what's the -1 tell me to do? Down 1, yeah. Yep. So if the number's outside, it's moving it vertically, right? And again, you're gonna see that up here as well. Okay? So the good news is, if you know this stuff, we're just learning it with our trig stuff up here. Okay. I had a marker I wanted to use. Use this one in dark blue. I like dark blue. Okay. So one little thing, we've been using what? Cosine of theta and then cosine of t. We're using thetas and t's. So for right now, we will swap theta or t for x. Okay, so we're just going to use x's now. So cosine of x, sine of x. It just makes it a little bit easier to work with. But again, it's not changing anything when it comes to these guys. Okay, so instead of doing y equals cosine of t, we're just going to do y equals cosine of x. Because when we were graphing things, you're used to seeing x and y. But again, I'm not changing anything. It's just changing the input variable. So let's take a look at our unit circle again. Here it is. Let's look at these 4 critical points. So at this point, it's 1, 0. Up here is 0, 1, -1, 0, and 0, -1. And going around the circle, so this is 0, this is pi over 2, this is pi, 3 pi over 2, and then we're back here, a full circle, which is 2 pi. So there's my unit circle. And what I'm going to do is break it. I'm going to, I'm going to break it right here. Just take it apart, and I'm going to stretch it out, okay? So let's do that. So I'm not here. Sure. All right, so again, I'm just going to break this apart. So these values are now going to be my x-axis, okay? So looking at it, that's going to be pi over 2, pi, 3 pi over 2, and 2 pi. Okay? So again, I took this, just unwinded it from the circle, and just laid it across here. Okay? And then my y-axis is still going to be 1 and -1. So here's my y-axis, there's my x-axis. Oops. Change that, make there. Okay. All right, so far so good with that? So do you see how we changed the unit circle, not changed it, but we made it into a nice little grid, an XY grid there. Okay. Now, using that, let's graph sine. Okay, now that we have this out in play. So now, let's graph y equals sine of x. Okay, we're gonna graph it right on that grid for us. So let's plot some points first. Okay, so at 0, what's sine of 0? 0. Yep. So I'm gonna use red. So 0, 0. There we go. There's our first point. Okay, next, pi over 2. What's sine of pi over 2? Yep, 1. So let's put a point right there. We okay with what we're doing so far? We're just plotting points. We'll connect them. We will get there. Pi. What's sine of pi? 0. Okay. Sine of 3 pi over 2. -1. And then we're back up to here, so that's going to be 0 again, right? Okay. So we've got some points. Now to connect them, you might be able to see what they're going to look like. But here's how we're going to decipher how we connect them. From here to here, sine goes from 0 to 1, right? So as it's going in this way, it's increasing, right? Does that make sense? So from here to here, we're increasing. Boom. Okay. Now sine's 1, right? It's now going down to 0 again, huh? So in this direction, it starts decreasing. So now we're going to turn and start decreasing. So we're at 0, and it goes to what, -1? So we're still decreasing. So to go from here to here, we're still decreasing. And then our last part, we're going from -1 to 0. So now we're back to increasing. And there we go.
Sine wave.
That's your sine wave. So that's telling you what's happening with sine, its values, when it's increasing or decreasing. Okay? And when is it 0? Well, when it hits the x-axis here, huh? So there it is. That's pretty cool. Any questions? Okay. Now, this is one cycle. Okay? Now, what do I mean by one cycle? Could I continue the graph? Could I just keep going forever with it? Absolutely, right? Okay? So for example, I'll put this underneath. Let's say I went beyond 2 pi. And I'll move in a moment. Let's say I went one more rotation around the unit circle. And let's say I went in the opposite direction as well. So instead of pi over 2, I'll have negative pi over 2. These are all just become negatives. There we go. Okay, so now I'm expanding it. Now I'm going to put 2 cycles in this direction, so I'm going to do it twice, and I'll do the same thing in the other direction. So you can kind of see like the full scale of this thing. So just kind of copying this down. Okay, so here is what we just did. Okay, that's what we just did right there. That was our sine wave. Now, if I go around the circle fully, does it repeat the same pattern again? It does, right? It's not going to change. So again, it's going to come up, down, down, and then back up. So there it is. That's me continuing that sine wave. Okay. Now, going in the opposite direction, okay, negatives are telling me instead of me going in this direction, I'm going in this direction now, right? So I'm going opposite here. So that's going to go down, up, up, down, down, up, up, and down. Okay? So, just like this. Okay? So, this, from here to here, is one cycle. From here to here is a second cycle. Okay? And the negative direction, same thing, right? From here to here is one cycle. And then from here to here is two cycles. Okay, so that's 4 cycles of showing what the sine wave looks like. Okay? Now if I just ask you to graph it with one period, well, one period we know from last lessons is 2 pi, so you just stop here. But if they ask you to graph more than one period, like graph 2 periods, well, it'd be this guy right here. Or you could do from here to here, that'd be 2 periods. It just depends on what range they want you to do it with. Okay? All right. Questions? Cosine's next. Let's take a look at cosine. Let me draw another unit circle. There we go. Okay, so there we go. So again, you don't have to draw the unit circle. I'm doing that so we can discuss like what's the behavior of what's happening here. Okay. And then I went ahead and drew another x and y axis here. Oops, probably should note that. Okay. All right. And let's plot points again. So right here, if I plug 0 in, we know cosine is the x-coordinate, so that's 1. So there's my first point. Pi over 2, cosine would be 0. At pi, it's negative 1. 3 pi over 2 is 0, and at 2 pi, it's 1. Are we okay with how I'm plotting those points? I'm just plugging that value in, and what is cosine of it? Now graphing it, you could probably tell how to connect the dots, but we'll use the unit circle to decipher what's happening. So cosine starts at 1 and then goes to 0, so it must be decreasing. So from here to here, we're decreasing. And then it's at 0, now it's going to negative 1. It's still decreasing, so it comes down to this point. Then it goes from negative 1 to 0, so it's increasing its value again. Oop. And from 0 to positive 1, it's now increasing, so up to here. So there we go. There's our cosine wave. Okay. Now, some things to think about here. Sine and cosine kind of look familiar, the graphs. If I were to take this graph and just shift it over a little bit, like move this part over, like this goes to here, and just expand just a little bit, you can see how it's gonna tend to do like the same thing as cosine's doing. And the reason why that works out that way is, remember how we said that they're complementary to each other, they're co-functions with each other? So let's do this. I think it's gonna look cool. Let's put them on the same graph. And then we'll start messing with the graphs a little bit. We'll start adding some things to it, okay? So putting sine's graph in, and let's use different colors. What do I have? Purple. Purple's nice. Let purple be sine. if you look at those two waves, if I were just to shift the sine wave over by pi over 2, it would be identical. So that's one thing to note there, that these are very close to each other. And we know that just from doing the cofunction identities that we did in the past. Just by shifting that sine wave over just by pi over 2 to the left, we get the same graph there, which is awesome. It's really cool stuff. Okay, let's list some characteristics of these graphs. Okay? So, characteristics of sine and cosine graphs. Okay. First, the domain. We talked about that yesterday. It's all real numbers, right? There's not one number that I can plug in that it won't work out. It's a continuous curve. Our range, well, it's -1 to 1. If you look at our y-axis, that's the largest value it could be. Our period is 2 pi. Okay. Now, just to let you know, if they wanted you to do another period of it, which we saw here when I extended it, then we would just redo the same graph again. So that was like 2 periods of sine there. But the reason why we don't really worry about that is because it just repeats the same values. It's still going to be -1, 0, 1, and so forth. Okay, a couple other little things. So the graph of y equals sine of x is symmetric with respect to the origin. Okay, so that means, we talked about this yesterday too, it's an odd function. And then the graph of cosine is symmetric with respect to the y-axis, which is because it's an even function. Okay. And the last thing, I'll put here the graphs of sine of x and cosine of x. They only differ by a horizontal shift of pi over 2, okay? And that's because of their complementary nature. All right. So, any questions? And if you think about just what you encounter out there in the real world, there's a lot of things that we encounter that looks like a sine wave. Okay, one of the largest examples you can think of is temperature. Temperature goes in a nice sine wave. You know, you have a certain temperature at the morning, goes to the afternoon where it kind of peaks, then it starts dipping down in the evenings, and then night you get your low, then you repeat. Okay, so it has a lot of good application to it. Next up, let's look at a sine graph, but I'm going to put a number out in front, and we're going to see what happens to it. We're going to have some fun with it. We're going to experiment a little bit. Okay. So, quick little definition with it. For the graphs, value of the vertical scaling factor, which we're going to call A, is called the amplitude. Okay. The amplitude is half the distance between the max min value of a function. And we're going to see that in the example. Okay? So if we have a number out in front, doesn't matter if it's positive or negative. We're just more concerned with what is the number. Is it a 2? Is it a 5? Whatever it is. Okay, it's going to stretch my graph by some factor of that. And we call it the amplitude. Okay, so the amplitude is us changing it. So let's look at an example. Let's say you had to graph -4 sine of x. So let's go ahead. Let's put our values in. Pi over 2, pi, 3 pi over 2, and 2 pi. So right now that's not going to change. We're going to still use those 4 values. Now notice I didn't put the scaling yet. Okay? There's a reason why. Typically it's what, 1 or -1 we would put there. But that 4 is going to change it. Okay? And it's also has a negative out in front. So there's something else happening there as well. So with the negative out in front, what happened to it with normal functions? What did that negative do? It reflected it, right? So this one's going to have a reflection as well. So there's 2 things happening here. Okay, it's going to be reflected. So this purple graph, so it's going to look like this, but just flipped. Okay, and that 4 is going to end up stretching it a little further. And just to prove that to you, I'll do a little XY table so you can see it. And you don't have to do an XY table, but I'm just doing that so you can kind of see what's happening. So my X values are going to be what I wrote up there. Okay. Now if I plug them in, we're going to see what my outputs are. So if I plug pi over 2 in here, I know sine of pi over 2 is 1. Times -4 is -4. If I plug pi in here, sine of pi is 0. 0 times -4 is 0. So is my lowest, just stopping there, is my lowest value -1 now? No, it's -4, huh? Okay, so already we can see it's stretching it a little bit further. Okay, 3 pi over 2, okay, for sine is a -1 times a -4 is a +4. And then 2 pi of sine is 0 times -4 is 0. So it looks like my maximum value is 4, my minimum value is -4. So now I know how to scale this. So 4 and -4, okay? And now we're going to plot some points, which we already did in the XY table, so we don't have to worry about that. Oh, I didn't put 0 in. Well, 0 is 0. Sine of 0 is 0, and -4 times 0 is 0. Pi over 2, we said it was -4. Pi is 0. 3 pi over 2 is +4, and then 2 pi is 0. I kind of missed that point. There we go. Okay. So there's the graph. So did it stretch it? Yeah, it did, right? It got a little bit longer than what it was originally. And it is reflected. So if you look on this purple graph here, this little hump came down here, and then this one came back up here. Okay? So the amplitude is just changing how far it's being stretched. So the output values are actually bigger than the 1 and -1. Okay. So far so good? Okay. So that's the amplitude crossed off. Now let's look at, what if we put a number inside? Okay, what happens to it? It's going to change the period a little bit. Okay, so I'm going to erase this. This is where I wish I had whiteboards that you could just like scroll to the ceiling so you still have them. I hate erasing these. Oh well. It is what it is. Okay. So, I'm going to jump to cosine next. And I'm going to show you what happens when we put a value where the input is, okay? I'm not going to keep doing it for each one because that drags everything out longer. So let's look at cosine here. So what would happen? Well, given a cosine graph where our b value is positive, okay, we have y equals cosine bx. I'm not giving you a certain b value yet, okay? I'm just telling you it's positive right now. Okay. Now, one thing we know, cosine completes its cycle within 2 pi, right? 2 pi, it completes a cycle there. So let's write that down. So we know that cosine completes a cycle on the interval 0 less than x less than equal to 2 pi, okay? So we know that's, and again, if we go beyond it, it just repeats those values again. So that's its period. So what I can do, if there's a number out in front, I can plug this into here and then solve for b, or I'm sorry, solve for x, and see what that's going to be doing to my period. Does it stretch it? Does it make it shorter? What happens? Okay. So let's go ahead. Let's plug it in. So we get 0 less than or equal to bx less than or equal to 2 pi. Okay. And then, well, just divide by b. So 0 less than or equal to x less than or equal to 2 pi over b. Okay. So if we want to know what our period's going to be now, it's going to be 2 pi divided by whatever that number is. That's going to give you my new period. Okay? So, therefore, we'll put up here our period for sine and cosine, whatever it is going to be 2 pi divided by whatever our b value is. Okay, so that's where the formula comes from. A little bit of manipulation. Okay? So, what I'm going to do underneath here is just summarize it. So amplitude and period for sine and cosine functions. Okay. So for this one, oops, for sine and cosine. Oh man, can't write today. Okay, so for sine and cosine, those two graphs, and given that b is positive, the amplitude and period are falling. Okay, so amplitude is whatever is in front of it, and the absolute value is there because again, it didn't really affect how far it was stretching. Like over here, I know it's -4. The negative just meant it reflected, but it's still telling me that the lowest and highest was 4 and -4. So that's why I'm not really concerned with the negative sign. And if I want to figure out the period, okay, how far is it going to be going out? I take 2 pi and divide it by whatever that b value is. Okay? So let's give it a shot now. Example. So we have this function, 2 cosine of -2x, and we're going to graph it. Okay. We're going to see what happens to the cycles, like what happens to the period of it. So first, let's identify the amplitude. So the amplitude is the number out in front. So the absolute value of 2, 2. So that tells me that cosine's graph is going to stretch up to 2 and -2. Okay, so we know what that is. All right, the period. Okay, well, we're going to take 2 pi and divide it by our b value. Now, looking at this, I have a negative out in front, right? Does that affect cosine? It doesn't. If you remember from the prior lesson, because of its properties, negative of an angle is the same thing as cosine of its positive angle, right? We talked about that yesterday. So what I'm going to do, I'm going to just rewrite that here. So this is the same thing as just cosine of 2x. So the negative is not affecting this. We're just using that property. So b value is 2. I don't have to worry about the negative at all. Okay. So for this one, my period is pi. So that means it's going to complete its whole cycle by pi, not by 2 pi. Okay? So that's what that 2 is doing. It's speeding it up. It's going through a whole cycle a little bit sooner. Okay? Last thing I want to do, tell you what, let's graph it first. Let me draw the grid first, and then I'll show you how to come up with these values, because I can't use pi over 2 pi, 3 pi over 2, and 2 pi anymore, because that 2 is out in front. I'm going to show you how we can fix that. So I know the amplitude is 2, so 1, 2, 1, 2. Okay? Now what to put here? Well, here's the nice part of it. I know that these guys right here, these are critical points, because you get exact numbers, right? It's not like fractional numbers. You get 0 or some integer. So because of that, because there's 4 of those guys that we're looking at here, we're going to divide our period by 4. So I'm going to put increments, which just means what do we put here? You're going to take your period and divide it by 4. So my period is pi divided by 4, so pi over 4. So each one of my scaling is going to be pi over 4 for each one of those. Okay? So we get pi over 4. I'm going to add pi over 4 again to get the next one, which will just be pi over 2. Add pi over 4 again, you get 3 pi over 4. Add pi over 4 again, you get pi. So I'm not going to go any further. I'm done because this is my period pi, right? It's not going to go any further, so I'm done. And I'm going to go a little further just to show you something though. Spoilers. I'm going to extend it a little bit more. Okay, we did everything. Now we're just going to what? Plug some numbers in and see what happens. So if you know what cosine looks like generally, you can get to the graph rather quickly. But if I were to plug 0 in, cosine of 0 is still 1. 1 times 2 is 2, so that's good. And then using the same properties, pi over 4 times 2 gives you pi over 2, which is 0, times 2 is 0. And then doing the same thing, just to save a little time, those are other points there. So here we go. Oh. Okay. Now, this is good, but I want you to see the effect of it completing its cycle sooner. So what I'm going to do, like this is the problem it's done, I'm going to go ahead and extend it to 2 pi, and you're going to see how it completes the cycle sooner. So over here, I'm going to keep adding pi over 4. So this will be 5 pi over 2, 3 pi over 2, 7 pi over 4, and 2 pi. Okay? So this is, I'm going to put it underneath here. This is one cycle, this is one period. Okay, so one period, we're done. But typically, isn't cosine going all the way to 2 pi? So it finished it sooner, but I can continue the process just to show you. So that 2 that was here means it's going to complete its cycle twice. So it goes through its whole entire process twice by the time it gets to 2 pi. So that's what this did to its period change there. Okay? Questions on that? Is that looking pretty good? If this was a fraction, it would take a little longer to complete a cycle, right? If a number that's bigger than 1 means it's going to complete it more than once, then a fractional amount means it's going to take longer to complete one cycle. So it's going to be beyond 2 pi. So it's going to look more stretched that way. Okay? Sounds good. Let's keep on going. So we talked about period changes. Now let's talk about shifting. Okay? Shifting the graph a little bit. Okay. So next example. So we're going to be given y equals sine of 3x plus pi over 2, and we want to graph it. Okay. Now, we know that what's inside here is going to shift it horizontally. We do know that. We also know from algebra that if there's a number in front of this, it's not really shifting it this amount. We have to factor this out of both. Okay, so we did that in the past. So that's what I'm going to do. I'm going to take 3 out of both of these to see where it's truly shifting. Okay, so that's going to be my first step here. So we're going to get, keep the same color here. So we have y equals, so it's going to be sine of 3, so I'm taking a 3 out of both. It becomes x plus pi over 6. So I'm just dividing 3 out of both of those. Now I can see that it's shifting. What direction, left or right? Think about algebra, what we did in the past. It's a plus sign. Left, pi over 6, huh? So my sine graph is going to be shifted to the left, okay? So let's run through the gauntlet here. So amplitude, let's start with that first. There's no number out in front, so it's a 1. So amplitude's 1, so it's not being stretched at all. We do know that. Okay, our period, we take 2 pi and divide it by our b value. My b value is 3. So 2 pi over 3, that's where it completes its full cycle in that range. Okay. Now, our increments, meaning what are these guys going to be for us? So that we hit our critical points, so we don't have anything goofy. We're going to take our period, which is 2 pi over 3, divided by 4. Okay. And we get pi over 6. So I'm going to add pi over 6 each time on the x-axis. That way we can get our critical points nice and smooth there. Okay? So let me go ahead and draw a nice little graph. We know that it's going to be 1s for the amplitude. We know that it's being shifted left pi over 6. So I'm going to put here negative pi over 6. That's where it's going to start. Okay. And now I'm going to continue to add pi over 6, right? To get my other ones. That's my increment. So I'm going to add pi over 6 each time. But where do I end? I know it has to go a full 2 pi thirds. So how do I figure out where it ends at? So here's how you do it. So we know that we're starting at negative pi over 6. The graph is going to end at negative pi over 6 plus 2 pi over 3. Okay, we're going to add our period to it. Okay, so when you do that, and what I'm going to do is just save a little time, and we know how to add fractions together. It's going to be pi over 2. Okay, so it's going to end at pi over 2. It starts at negative pi over 6. So that way we know if we're stopping or not. Okay? So before I fill out the x-axis, do we have questions? When you graph this yourself, go in that order. Start with amplitude. What is it? What's the period? What's the increments? If there's a shift, where do you start? Where do you end? You're just going to keep following that pattern no matter what sine and cosine is and whatever is happening here. Okay? All right. So let's start adding pi over 6 to everything. So this is what we get. Okay. Again, I'm just kind of saving us some time. I mean, if I add pi over 6 to this, I get 0. plus pi over 6 gives me this, plus another pi over 6 reduces to pi thirds, plus another pi over 6 reduces to pi over 2. So I'm just, again, saving some computation time. Now, we know what we know what sine looks like. It starts at 0, goes to its highest point, then starts decreasing to its lowest point, and then bounces back up. So we can use that pattern to plot our points. Just like that. But again, if you want to, you can plug it in. If I plug in negative pi over 6 to this, it's 0, 0, sine of 0, 0. So you could do that individually. But if you know what the trend is, what sine always does, you're just redoing it each time. Okay? All right. Any questions on that? Kind of working out? I like graphing these. Like I said, I think they're more interesting than graphing polynomials, and not that they're bad, but these are more fun. Okay. So now we got to talk about, well, I tell you what, I want to do one more thing with this, and then we'll talk about like shifting vertically, and then we'll summarize it. Okay. So looking at this, so going back to our example, which was this guy. Okay. The graph, shifted pi over 6 units to the left. The shift is called a phase shift. Okay, so if you ever hear the word phase shift, that's you just moving it left or right, depending on what the graph looks like. Okay. Now, how did we figure it out? We just factored out the b, right? That's what we did. So to figure out where it was moving, I just, whatever that number is, I factored it out. Okay? To make it easy. So let's look at a generic graph. So let's look at y equals a sine of bx minus c. Okay, or cosine. Cosine wouldn't change anything. It's going to be the same process. Okay, we can determine the phase shift by solving this. Okay, so we know that sine and cosine have a period of 2 pi. So what I can do is I can take this entire thing, substitute it inside of here, okay, and I can solve for x, just like I did before. And the result shouldn't be surprising. The result's going to be what we just did over here, me factoring that out. But I'm just proving to you that this is what it is. It's going to give me a formula at the end that you could use, and I'll talk a little further than that. But anyway, I'm going to add c to both sides. And then divide everything by b. Okay. And we can see that this right here was our phase shift. That's where we moved across by dividing by whatever b was. And we divided that by 3. Okay? So this right here is technically the formula for finding your phase shift, which is what I did there, okay? But the textbook, and a lot of textbooks do it, they show you the formula, but I don't use the formula. I just, whatever that is, I just factor it out. But I still want to show you that in case you want to use it instead. Okay, so we'll put here, just to finalize it, so our phase shift formula is C over B. So if you want to figure out how far it's going left or right, bless you, you take whatever the C value is and divide it by B. Okay. Now we're going to put everything together. So we're going to put this together, and then we're going to include a vertical shift. And that's probably where we're going to stop. I have to still show you how to model this behavior with an application. We'll do that tomorrow. It's just one example. But let's finalize what this is. So we got y equals 2 sine of negative pi over 2x minus pi over 4 plus 1. So now I'm going to apply a vertical shift to this guy. Okay, the original equation I'm going to manipulate a little bit. Before I even start graphing it, let's deal with what's inside of here. So y equals 2 sine. I'm going to take a negative pi over 2 out of both of these guys. So I'm going to divide it out. I get x plus a half. And you can check. I mean, if you multiply this back through, you get the original. Okay, so that's the first thing I'm going to do. Which kind of helps, because now I can kind of see, like, hey, there's a shift going on, and I can know what direction it's going in. The second thing I'm going to do is this. If you remember, sine of a negative angle is the same thing as the output being negative, because it's an odd function. So I can go ahead and write it as negative 2 sine of pi over 2, x plus a half, plus 1. So this is what I'm going to graph. Okay? So I had to do a couple changes. And again, it's just to help you see what's happening here. But this right here, from the last lesson, if the angle inside of here is going to be negative, then it's the same thing as the negative going on the outside. If you remember one of the examples that we did, when cosine had a negative angle, it just didn't change nothing. It's the same thing as its positive value. Okay, so we're going to graph this guy. Let's list some facts first. Start with the amplitude. So the amplitude is the number out in front. We don't care that's negative. It's just a 2. But I will put a note. Because it's negative, we're going to have to reflect it across the x-axis. So we will make that note there. Okay. Next, let's look at our period. Okay. So it's going to be 2 pi over our b value. Okay, so our b value is pi over 2. Simplifying that, we get 4. So we don't have to worry about pi. It ends at 4 units. Which kind of sounds weird, but it does work out sometimes that way. Okay, how are we going to scale this? Let's look at the increments here. So we're going to take our period, divide it by 4, and we get 1. Hey, that's even better. We're going to count 1, 2, 3, 4. This is working out nicely. It's almost like I planned it that way. Phase shift. Sometimes I plan it out that way. Making up your own problems, my gosh, it is exhausting. Because you're like, I want this to happen, and you try to create something and it doesn't work out that way. But this one did. Okay, so where is it moving? So it's plus a half, so is that left or right?
Left.
Left. Okay, so it's going to go left a half. And the last one, vertical shift. And then we can start graphing this. So it's going to, what, move up or down? Up, right? So up 1. Now this is going to be interesting. So that means I'm going to take, we'll use this as an example. I'm going to take this whole thing and just move it up 1. Is what's going to happen. Okay? All right, let's draw our little plane here. I know that the amplitude's 2. So there we go. Okay. It's going to go left a half first. And I'm going to increase it by 1 each time, right? So the next one, so if I add 1 to this, it's going to be a positive a half. And this will be adding 1, so it'll be 3 over 2. Okay. Adding 1, 5 over 2. And then the last one would be 7 over If you want to put decimals, you can. Do you want decimals? Would that be better? Are you okay with fractions? I won't be picky. If you want to put decimals like 0.5, negative 0.5, 0.5, 1.5, 2.5, 3.5, you can if you want to use that. Okay, now, how do we handle this guy? So here's what we're going to do, okay? It's going to shift my graph up 1. So here's what it's going to shift the x-axis up by 1, okay? That's how we're going to do it. So I'm going to pretend this dotted line is my new x-axis for right now, okay? So I'm going to ignore this, which is going to feel weird at first. I'm going to start with this. Now because of that, I'm going to have to add another couple marks up here because my amplitude's going to go a little higher now, okay? And I think we're good. I think we're good to start plotting points. But before I do that, to finish it, any questions? Are we okay with how we did this? And every time you approach a problem, just do what I did. Amplitude, period, what's the increment? Is there a phase shift, vertical shift? Plot this, now we can start plotting points. Okay, I'm gonna outline this in red. We don't wanna forget that. A typical sine graph, I'll put it over here, looks like this. That's what sine looks like. But because it's being reflected, it's gonna be a little bit opposite there. Okay, now let's start plotting points. So this is my x-axis, this is where it's 0 now. So if I plug negative a half in, it gives me 0, sine of 0 is just 0. But with the plus 1, it's gonna put it right here. Now we're gonna go ahead and plot some other points. So just for time's sake, I'm gonna do that real quick. So down here, what was the amplitude? 2. So 1, 2, so it'd be here, then here, up to here, because we're adding 2, and down to here, because we're going back down. Okay, so now we're going to connect them, and there we go. So again, this is your wow, I really missed that, didn't I? Wow, there we go, better. It's more like, we're gonna make these really big. That way it looks like I actually hit them. There we go. It was obnoxious. But there's our graph. So it is reflected, we could see that. It did get shifted over, okay? And it did get shifted up by 1, okay? So imagine this going up just 1 tick above it, okay? Now again, when I graphed it myself, I know what the sine wave looks like. So it's easy for me to figure it out. But if you're still not sure of it, because you're just learning it for the first time, you could plug these points in, make an XY table, and get to that point, which I encourage you to do if that's something you're not quite confident in. Okay, so tomorrow, I promise, it's just one example. It won't take long. And that's it. That's graphing these guys. Any questions? You guys are awesome.